Okay, you guys start writing any computer code in the CIS 151? But you're using Unity, right?
Well, not really.
I mean, are you making anything?
No, just a game development document.
Okay.
We're covering like theoretical stuff like what is a loop and a if statement. We did that last week, but it's all just theory. Apparently the follow-up course is going to have some coding. But yeah, I spoke with the professor and he said there's nothing he can do because apparently the syllabus, that's just what the syllabus is, so this is the content he has to teach. He says he would prefer to give more practical things like programming. But yeah, unfortunately, this is what the syllabus requires.
Mm-hmm. Hey, Tommy, Bo, you guys can hear me, right? Give me a thumbs up in there. Are you taking AVC 200 next semester? Okay. Here? Okay. Yeah, it's table. Okay, let's bring some stuff back into Blender here to start assembling our scene and then kind of go from there with this. Yeah. Okay. So once again, SP back to Blender. If we export the USD, which stands for Universal Scene Description. That gives us all of the stuff all together, right? The geometry plus all of the textures and materials, and it all gets, as long as we have Node Wrangler add-on installed, I think that you should have that installed regardless, then it definitely, everything happens there. So let's bring this in here and then start working on that. So in here, we'll go to export textures. We'll make a folder for this stiff in here. And this is going to be table scene. And in here, Blender. Then make sure that we're telling it to export the asset. And yeah, Jack has both of these set to 2048, which is fine. That should be good. Again, if you start to make these too big, then one of the things that will run up against more quickly here is just the amount of RAM on your GPU, which again, this is just, just knowing a few technical things can help you, even if you want to just solely identify as an artist who doesn't care about technical things. There's two places. There's the RAM on the motherboard, and this is used by the CPU. Then there's the VRAM, with the video RAM, and this is used on the GPU, the graphical processing unit. These are two different things. You can see them in the task manager in here, and in CPU, or actually, CPU is just your core usage. However, everybody's CPU at this point has multiple cores in it. And so you can say, change view to logical processors. There we go. And you can see what's going on. So this is both the good and still substantially limiting part of computing. We've built all these CPU chips that have multiple cores, some sort of multiple of 2, maybe 12, 24. There's this other issue of like virtual cores. I don't really understand where one core is treated as 2. That's all sort of beside the point. The main issue here is that if your computer takes advantage of it, it's not the computer. If your software takes advantage of all of the cores, it's what's referred to as multi-threaded. And why not multi-thread everything, right? We've got all these cores. You don't want them sitting around not doing anything, right? The problem is this is difficult. I don't really understand the hardware, down to the metal applications of this, but the fundamental principles, as far as I understand, of what you think would be complicated is the complicated part. Where if I give Jack a job and I give Arlinka, or I take the same job and I give half of it to Jack and I give half of it to Arlinka, and one of them finishes first, then what happens? Well, I need to wait for the other one to finish until I can turn the job in, right? And so, as far as I understand, this metaphor holds true when we're multi-threading something, is that this just idea of synchronization becomes like a considerable barrier. Yeah.
That's why if you get an RTX 5060 or whatever, it's not going. You're actually going to shoot yourself in the foot if you get two and try to run them together.
Yeah. Running 2 GPUs is like, that especially because the GPU is not really designed to like send the info back to the computer so that it can be synchronized with the information coming from the other GPU, right? So yeah, all of this stuff, on the surface, it sounds like, yeah, we'll just get more chips and then we'll do the thing faster. But like, that's, upon further inspection, that whole thinking breaks down quite a bit, right? You got to take a job, divide it into different parts, send all the parts out. Like, even though all of this is happening very, 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 very fast, like in, milliseconds and nanoseconds, like it's still, if you're assembling some sort of sequential data, it still needs to happen and get assembled in order. Yeah, and then if there's logical processes, that's yet a further level of complication, of sophistication and complexity there, right? If there was a decision made on core 2 in an if statement that affects the entire world, but core 8 doesn't know about it while it's computing something that's dependent on whatever happened on core 4, then yeah, this stuff is difficult. This wasn't an issue before when it was all just 1 and everything got very, very quickly computed in order. In, you know, the opposite of it being multi-threaded, right? The multi-threaded stuff here, the word that you should know is parallel, right? This is parallel processing, and the opposite of this is serial. When we do one thing, then the next thing, then the next thing in one big list, super, super fast. And so, you know, this, the only variable you have is moving something up or down the list. Whereas this becomes a much, much more complex situation, which is not trivial to solve, which is why it has not been solved in many cases, where, you know, the making something parallel would not matter. But over here, memory, this is actually your CPU memory. And can you see the individual sticks? I don't think you can. You just see the total amount. So your computer has multiple sticks of RAM in it, and they get they're always in doubles as well, and then they need to get divided up here. And then under here, our GPU, instead of having two separate tabs, because this is all on one big card, the GPU card, that's where the VRAM lives. We see the, you know, processing power here, and then down here, this is the dedicated GPU memory usage. And so down here, you can see exactly how much GPU memory you have and how much is currently being used. And so this, knowing where this number is, so you can at least glance at it, is useful, especially now because we're going to make all these super pretty textures. The textures are big. That is far and away the thing is you're gonna bump up against first, right? We're not going to turn on so many things that the render time is going to just crush, right, in terms of how long it takes. Far before that, especially because you know how to use Substance Painter now and you know how to make these big textures, you're going to run up, this will be the first, you know, hardware barrier you run up against. And so you can check it, as long as you have like other stuff on your computer closed and you're not running God of War Ragnarok while you're trying to run your Blender project at the same time. Like, you shouldn't do that, right? Like, it's a real thing. In fact, if you really care, you would close Chrome, because like that's also has a, you know, surprising amount of resources it's eating up. Yes.
When I just started the stuff, I rendered stuff out in like Unreal and Substance Painter, and I was crazy enough to play Darksiders alongside the renders on my computer.
And just
Start chugging.
Yeah, just quadrupling your render time, and then also possibly setting your computer on fire at some point. Just hear all the fans go. Yeah, so that's where that stuff is. Of course, I have a bunch of stuff open at the same time. We don't need to have Unity open right now. We can save this and close this. Anything else? Unity Hub doesn't really do anything, but yeah. So I have a bunch of monitors at home, and I usually have this open. Like if I have one free, I throw Task Manager up there so I can like have some idea what's happening. It also, like, being able to just glance at those graphs, I find also helpful. Like when something crashes, you can sort of see like which graph spiked a lot, and that can sometimes give you some clues as to like, like sometimes you can be like, oh, it was this thing I did. I probably crashed it. Sometimes you don't, you know, get any clues, but yeah. Okay, so we got our asset, everything else is together. Let's use our Blender BSDF and export. And let's bring this in over here. And we should be able to import this stuff. in here, in here, and yeah, so you get a bunch of stuff. Just once again, the one that says geo.usd is just the mesh, no materials or textures. The textures are all in this folder. You can see them all there, right? So now when you open stuff and you see something like this should make some sense to you as to what's going on. And yeah, right? So now you know enough that like, oh yeah, this is the metallic for the chair. Jack just painted those like screws that were on holding it together. And so those were really the only metallic parts. And so hence those specks of white on the whole thing. And then back here, the one that just says USD is essentially this is, you can tell what's happening here. This is essentially just like a, text file, maybe JSON or something that just references all the data in the other stuff, right? It's only 1 kilobyte. And so we can drag this in and import. And let's just double check that the scale is good, right? And so our scale here, this is going to be 1 meter. No, 2 meters. Yeah. Yeah, the default, I might have changed that. Whatever, you can sort of check in here, right? So again, 2 meters is about how tall? 6 feet, yeah, right? 1 meter, around 3 feet, also the size of a yard. How many feet in a yard? Yep. How many inches in a foot?
12.
There you go, all right.
I thought this is a modeling class, not a math class.
Oh my gosh, I'm just talking about multiplying by 3. I think you need to be able to clear that bar to do this stuff. Yeah. It's not like I'm asking you to do ounces, which is like a veritable landmine of metrics. There's like liquid ounces and then like solid ounces, and then there's like other issues there. Yeah. And just for the record, I'm pro metric. Like the fact that we're still wasting, I mean, think about it. Like how much conversion has to go on between the United States and the rest of the world to get this stuff to work, and how much is still messed up, right? Like, is it billions of dollars that are wasted every year in productivity because of these like failed metric to imperial conversions? Like,
Apparently NASA blew up a rocket because they use metric, and apparently someone used the imperial system in the fuel calculation by accident.
mm-hmm.
So the fuel rocket just blew up.
Yeah, I'm sure like the history of science and business is littered with like these idiotic situations where like, yeah, anyone like quote unquote doing science is using the metric system because it's like the global system for communication. And it's great. Like, like it certainly makes way more sense than, the imperial system, which just seems like a bunch of haphazard nonsense.
Also, the imperial system just looks uglier because of all the decimals.
It looks uglier. It has this really problematic name, like all around. Like I'm just not. Ugh. Cool. And so everything's here by default, which is wonderful. And if we come back over here and look at our shader view here, just like this. Oh, we got to drill down over here. There we go. Oh, am I in edit? Thank you. There we go. I was like, what is going on? Here we Yeah, so it does all of this for you, which, not to be undersold. It doesn't organize it super well, so like maybe some node, doing your own node wrangling here, right? And so having all of this use the UVs is obviously what we want, and probably organizing it like this is obviously some of what we want. We have our normal going into the normal map, our roughness going into the roughness there. The main thing here, right? So the part about running the named thing into the name is fairly obvious. I think everyone gets that pretty quickly. Unfortunately, there's some real gotchas in terms of the format. The main one being always, just like in Substance Painter, is this color data, meaning RGB, because then we're into a whole world of digitally representing color, color spaces, bit depth, a bunch of things there, right? Yes.
What's the difference between specular, diffuse, and roughness and metallic?
In the map?
Specular and specularity and I forgot the other one. Because like Substance has like two versions. It has a base color which is also diffuse, and then
Uh-huh.
it has specularity versus roughness, and it has metallic, and I forgot the other one's name. What's the difference between those two?
Yeah, it's just how it's organized, right? And then the underlying shader. So you want you're going to want to set the output from Substance to whatever your thing is. In Blender, let's look here. So with there's just not agreement about this value, right? So there's either some of them are organized as roughness values, where this is the one I see more often, where if you move it to the right, it gets more rough, and if you have it at 0, it's glossy. But then there are other shader organizations or codes that use a value called glossiness, right? And that's essentially inverted roughness, so that when you move it to the right, it gets shinier, as opposed to moving it to the right, moving the value up from 0 to 1 and doing that. So
So
the default is, and most of the programs, everything we're using, the default is roughness, so that you turn it up and it gets rougher, and that's the default in Blender. And in like Unity, if I were to open it up here, there's like shaders organized both ways.
So there isn't really any difference in terms of how it's rendered. It's just
I mean, in all these instances, there could be, depending on the shader, right? And so this just holds the data. How the data gets rendered is a result of this, which is why we have different pieces of code it's part of the picture. This is part of the rendering, right? Obviously the render and render settings are the other part. But if you shift A in here under shader, right, you've got diffuse BSDF, right? So this is another, code for shader code for like shader code, meaning it's code that's running on the GPU. A lot of times the code language for this is GLSF. Is that right? I have that right. The language for writing shader code. GLSF, GTSF, GLSL, yeah. BSDF and GLSL. GS, it's graphic language shader, graphic OpenGL shader language. So the GL being the GL and OpenGL, and then SL being shader language. And so stuff like this, not like that, that's HTML, stuff like this, right? So this is the code that actually runs on the GPU that takes in the data that's in your textures and renders it. So this is why there can be things that, you know, look good in Substance Painter, but then if you don't export them in the way that your render environment is going to evaluate the data correctly, then you end up with this issue, right? Or it just won't look right. So what other ones are open here by default? Yeah, so this is the other one, Glossy BSDF. I'm going to make a new thing and look at that. So here, and make a material for this here, and then get rid of this one and look at the Glossy BSDF, and then here, if we look at this, this is going into here, and then here. Now that one's still organized that way, even though it's called Glossy. Our code here is slightly different. Isn't there a second one here? I mean, they're trying to keep it all the same. Diffuse, glossy, hold out, mix, bold, volume. Yeah, those are all the same. But over here, in Unity, if you make a new material, some kind. Yeah, because of it's coming out of different things coming out of different rendering environments, even under Universal Render Pipeline here. Let's go back up. Oh, okay, yeah, it's like two shaders combined, right? So metallic workflow or specular workflow. So yeah, you see that this input here, essentially this is toggling between two versions of the code there. Whether you're providing a metallic map or whether you're providing a specular map, right? So depending on what you would send out of wherever you're designing your materials and textures, there's those two separate ways to structure it there. And then there's, separate from that, the glossiness issue in terms of like which way does that go? Does it get more shiny or more rough? Although it does seem like things have coalesced around roughness, which is, you know, whatever it is, as long as it's like not switching all the time there. But that's what all of these are. That all those green boxes in the shader graph, those are all these. They're just, you know, different pieces of code that are shaders that are going to load those textures and then render them on the screen. So getting the textures right is only the first part of it. You need to make sure that the textures are rendered in a way, or recorded in their textures sheet database with the proper format so that they get interpreted correctly by this stuff. Right? This is why we've been using a bunch of the Mixamo models in like 240, and whatever their setting is, I think that's a result of this glossiness issue, is that their Yeah, it's their roughness, I think, which is inverted, because that's how we've been fixing it, right? Haven't we been inverting, putting an invert node after? Yeah, okay. Yeah, yeah. Everyone who comes out of Mixamo, if you dump them into Blender by default, they look like wet and sticky, because they're just like their roughness is inverted. They look way too shiny. And so because of whatever the default, however it gets imported, the default there is the opposite of what would be the natural thing there. So yeah, I mean, in general, once you've got your workflow down, you can kind of stay on task here. Like, okay, this export gets everything formatted correctly for this shader. That looks correct. And the reason that Blender, has, the default is the principal BSDF is that the general consensus is that it's easier to just like, okay, I'm always going to use this, even though this has like a lot of junk going on, rather than having to load up a new shader if I want to do something different in the rendering, right? So regardless of whether you agree with that or not, like that's what they're doing, from their standpoint. Yeah, so there's that. Over here, we've got these. The other thing I wanted to call your attention to here is this, okay? So this is besides plugging in all of the cables, this color space thing that it's setting by default is really important. So that the ones that have color, which are going to be the emission and the base color, are set to sRGB, right? They are evaluating the whole thing. And then all 3 channels. And the other ones are not using a color space to interpret the data. Without getting into it too much right now, so this is in flux, and people are developing new standards for this. What are we? When you read the colors, right? The amount of red, the amount of green, the amount of blue. There's 2 primary complicating factors. One, what is the hardware able to actually display in terms of the brightness of the red, green, and blue? Then there's this separate issue of what do we actually see, right? So one of the fundamental things here to take away is, what do we see the best? Brightness. By a large orders of magnitude, our sensitivity to brightness is very fine-tuned. They've done all sorts of studies on this, even with your eyes closed. Like, people can sense there's like blinking, very small, very dim blinking lights. So we're able to see this. Next to that, once we start to break it down into colors, right? Because the RGB is not some sort of random decision. That's how our eyes work. Our eyes have photoreceptors that are tuned to red, green, and blue. So having the screens tuned to red, green, and blue makes a lot of sense from this standpoint, right? For those of you taking graphic design, this is not the case, right? Are you taking graphic design now? When you print stuff, what colors are you printing? CMYK, right? Cyan, magenta, yellow, and black. Yeah, I can't speak to the historical precedent there. At some point, it became easier, or the hardware, the technology sort of coalesced around those inks and those colors. I can't really speak to that at length. But the screens are designed because this is the way our eyes work. And the other thing you should memorize is which of these three are we most sensitive to? The R, the G, or the B? The G, yeah, by a lot. And so there's this, okay? And a lot of what's going on here, I'm sort of parsing some of this for putting together a thing together for AVC 100 and trying to figure out what the latest version of Blender is doing with the color space conversion stuff. So we can talk about this in the next few weeks once I have it worked out to the point where I feel comfortable going through the whole thing. But it's not without its complication, right? We have this, you have to consider how the data was stored, right? How the brightness was encoded. Is it strict linear, or is it encoded on some sort of exponential scale where it doesn't increase linearly? Why on earth would you do this? That sounds like it would be complicated. Yes, but this is the way we work, right? Both with sound and optical phenomenon. Like when you make a sound twice as loud, it doesn't sound twice as loud. You need 3 times as much dB, or reduction in dB, to make something sound quote unquote twice as loud. There's a bunch of, you know, we're in how we perceive things at this point, and so, you know, there's lots of really, really brilliant people working on all of this stuff, and there's been lots of amazing experiments done, right? And so a lot of this is kind of quote averaged, right, in terms of like how, and so there's variation from person to person. But yeah, there's how the data is stored, then there's how the hardware is displaying the data, and then there's how we're perceiving what it's showing. And so, yeah, there's different versions of doing this. I'm not going to get into that today. Just know that that comes back to this decision here, okay? Is that when we're not using color data, we're using this black and white, right? And the other thing you need to memorize is that when something is just black and white, the mathy word here is this is scalar value, just one number, right? One number per pixel, just a black and white number. And this needs to be correct in order to make everything look correct here, right? And so, for instance, if we, let me close this because we don't need it open. If we brought this back in, if we look at this over here, is anyone saying anything? There we go. Tommy, Bo, everybody still with me? If we do this, if we get out of this view and look at this render here, these are going to be slight differences, but you'll see differences. And so, for instance, if we take the, which one is this? This is running to rough. That's metallic. Yeah, there's not much metallic here, so we'll look at the roughness one. If I told the roughness one to be interpreted as sRGB data, okay, keep your eye on the table. We should, if I AB it, will it show up? I think so. Let's test that. Here we go. And so we'll use that testing that we talked about before. What do I have it set to right now? I have roughness set to sRGB. I mean, this will be a tiny, there should be some visible difference, but we'll see. Control Alt 0 and F12. There it is. And so this is in slot 1. We'll use that test thing. We've talked about this, right? Yeah. Slot 2, we'll set it to non-color, scalar information. And then we'll render again. And let's look at this here. And so there's slot 1, slot 2. Subtle, but you can see that, there's a shift here. In this table, there's, given the lighting and everything else, a little bit of a difference. So the fact that everything gets set up correctly in terms of this, in terms of that, and route it into everything else, that all works really well. Also, did you add emission to this, or did you just happen to use?
I feel like it's been adding emission to my files.
Okay.
On their own.
Yeah. So obviously we don't have any blinking lights on this table and chair here, right? And so the emissive is not necessary. And from the Blender standpoint here, it's still it's a separate texture that's getting loaded. And so you could probably save yourself a little bit of, actually, let's see if we can actually tell. If we look at here, here's our, okay, so down here are dedicated, well, it will be able to tell more accurately here. We're using 6 of our 16 gigabytes. And if I remove the emission, because there's nothing lighting up here, and delete this, I would need to make sure, and a 0, there we go. And then we look back here, let's see. And then we save. Save as. Yeah, okay, there we go. Takes a second to update, but you can see that we are using slightly less, I mean, not slightly, that's 500 gigabytes, right? So, yeah, the thing, it's less. Let me think about the other part that I was going to say there, because I'm not 100% about that. Anyways, yeah, I think Jack is right that Substance Painter in the newest versions has been using the emissive channel. If you just make a new blank file, the emissive channel is already there.
It might be because it's coming from Blender. So since Blender has I don't know. Like when I do a new file and bring in the FBX. Maybe because it's FBX, I don't know.
I have to manually
Manually add it. Yeah, I don't think that's true, but I'm not 100%. But regardless, like either if you're not using a channel, you don't want to load this entire 2000 by 2000 grid of pixels into your memory that you're not using, right? So I mean, this is why it takes a long time to load new areas in video games, right? You walk into a new area and then if the developers hide it well, there's like a tunnel that you're walking through, and then you get into the new area, and while you're walking in that tunnel, all of the textures for the previous area have been dumped, and the new textures have been loaded into the VRAM so that they can be viewed. So yeah, regardless, I mean, whether or not you export it and whether or not it's sitting on your hard drive, I mean, that's kind of irrelevant. Like it's not taking up that much space from that standpoint. But when it comes to actually, putting it in Blender and having it render the stuff, it makes sense to not have stuff here you don't need, especially if you're working on a machine where you're like, at the at the threshold of what is capable there. So with that in mind, we get this back. Let's bring in this is all correctly set up. We've got all of that. Let's bring in my fork. So fork. And here we go, looking good, fork. All right, so let's export this. I'm gonna make a new folder in the folder for the fork. And again, export. Yeah, no emission here, but we know how to handle it now. You understand what? No, exported it. Okay, so I may have adjusted the default Blender output here at some point. Perhaps. Regardless, we know how to handle it now. And so back over here, if I bring in more stuff, here, again, grabbing the USD, bringing this in, should come into scale, right? This is wonderful because we've taken the time at the beginning of the process to do the right thing and model stuff to scale. And that's looking good. And so everyone's understanding how that pays off. And let's see what's going on here. The fork looks not great. But maybe that's the emission. Let's see. Nope, the emission didn't get imported here. I thought Substance Painter said it was exporting it. Or did I just misread what I said, what I saw? Let's look in here. No. Okay, it's not there. And so what is the deal here? So I think, especially with metallic stuff, right? Most of what we're seeing, especially here, is the HDR, right? So putting something in place at this point to know, because remember, by default, it's nothing, right? Reflecting nothing. So let's put some sort of placeholder in there. Sure. Okay. And so now if we were to look at this, now it looks okay. I'm okay with the way it imported. I don't think there's something fundamentally wrong there. But like I said, it's, you record the textures coming out of Substance Painter, then they come in, they get loaded into a different shader. So let's say you want to make an adjustment. Should I go back to Substance Painter and make a change? I mean, is it some sort of like you need to paint part of it black or like put some red dots on it or something? Like, yes, you should go back there and do that. But is it something that like, I wish it was a little bit shinier or less shiny? Like, that's all changes you probably should make here, right? And so, for instance, the metallicness of it, right? The best way to make these changes is that we want to keep this data. We just don't want to overwrite it, but we want to change the way that it's, be able to shift it one way or the other way. And so our ramp is going to be the easiest way to do that. And so here in the roughness, for instance, if we put that in there, just by dropping it in after this, that should look exactly the same. I'm not entirely certain. Let's look. Yeah, looks pretty much the same. I didn't see anything really shift. Yeah, so the default ramp value should be completely standard. And so now, smushing this down to take the data and make more of it white or make more of it dark, or perhaps adding a new node in the middle. And this will sort of change the balance. You could take it and stretch more data over in this way to make it shinier or not. And so we have that. I have that one really bright point light I put in there. I'm going to turn that off so we get some more shadow happening. And yeah, so if you bring in your highly metallic stuff like your silverware and it looks terrible, there's nothing's being reflected. So the other thing, instead of bringing in HDR, the other thing you can do is this. The reason this is there, the material preview, is so that, what does this do? It automatically loads this HDR so that you can see this kind of thing right away, right? That there's some reflections in there so that you can make some judgments about what's going on with your material there. But remember that the HDR in this view mode is not the one that's actually in the render. So keep that in mind. But in terms of like getting a quick, like checking the metal, like, wait, did I do this wrong or does it just not look right? And you can just click over to that view to get that preview of it. Okay, we've got this in place. Let's go ahead and save this.
Scene from the Stanley Parable.
What happens in that game? I've never played that game.
It's a weird game. You're stuck in an office and you've got this narrator making quirky remarks. Like, you can either do what Stanley wants you to do, or the narrator wants you to do, or you could do what the narrator does not want you to do.
Mm-hmm.
And the narrator gets more and more angry the more you don't do what he does or what he wants you to do.
So it's like going to work.
So at some point, like, there's buckets involved because he realized that Stanley might be an idiot because he doesn't know what a bucket is. It's a funny game, but it's kind of like Uncanny Valley vibes.
Oh, okay.
So just like a table with one random spoon in the middle of nowhere just reminds me of that.
Yeah, so I mean, let's make it less, because Bo asked about this. He's like, I want to have more chairs, and so yeah, we want to, unless you needed the chairs to look different, like you can just duplicate the existing chair here. And so if I come into this one and Shift D, I can give myself more chairs with which to create my table scene here. All right, and Shift D. In fact, it's probably easier Once you have one that's correctly done, look down from the top, and it's much easier to set up, just to build your view from this way. Shift D, and then bring this over and bring it over like that. And now, we've got, this is looking good, right? And then same thing, obviously, with the fork. You'll have more stuff there, but and then Shift D, and don't do this. This is obviously weird, right? No one's, and so you can sort of angle stuff and perhaps come in then and this is another thing to be aware of. Zooming in here to be able to put things close is pretty useful, and then just making it look a little bit more haphazard there. And so that helps quite a bit to make it look like, like an actual thing, an actual place. And then in the view, like I talked about before, seeing the HDR in the background is, in most instances, not that great. If I can remember where this is, over here, if we don't want to see... Yeah, so camera settings, film, transparent, and so now it's still contributing to the light, right? And so even if we come down here and go back to looking at the world and then start messing with the rotation here, we see it is changing. Although, I think this is just a little extra light, yeah. And so here, that's going, and then there was the... strength. Let's turn the ray tracing on. That's right, that needs to be on. And then in the I totally forget where that fake light checkbox is off the top of my head. I think it's easier to do this on your own, right? So I've got this here. Let's make a light. Let's make an area light. So I've got this one. I'm gonna bring this over. We've done this in 240 a bunch, but I'm gonna take this thing and then give it a target. Shift A, and then empty, axis. There we go. It's come in. It's called this light target. And let's start figuring this out. So here, area light, we want to point at the target, so damp track to the light target, and make sure it's -Z. There we go. And so now, even if I move the area light around, it still points towards the target. Makes it much easier to art direct my scene here. And probably come in and scale up this area light. Cool. Okay, we're getting our scene set up here. ba, 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 ba. Thank you. Okay, good. So let's save that. Let's make some new stuff for our table. So we're getting this. This is happening. So we're going to want some wider shots, maybe some close-up shots. You can see at this distance, the small fork with 2048 looks pretty good. Seeing the table this close up maybe starts to break down a little bit at 2048. And so there's some options there. Part of that is going to matter with what we're doing with the camera. And so if I could Control Alt 0 here, let's come in and get a better view of this, maybe down here like this for now. I'm going to grab my focal length and maybe bring it in. And I'm also going to look through the camera. So view, camera to view. There we go. So I can sort of get this a little bit more how I would want. There we go. So I can see a little bit better what I'm doing. Just hit the home key. We're going to get some more stuff in this scene, but let's leave it at this for now. And let's turn this off and try to set up some shallow depth of field here with what we're doing. And so we want the forks to be in focus. And so let's look down from the top. And part of what we're going to do here is adjust the camera and the depth of field. So over here under render, depth of field. First we need to turn on the camera, depth of field. There we go. Now, what do we want to focus on? There's two different ways to do this. We can either dial in the focus distance, in which case I thought we saw. No, we're not going to. I thought for sure there was a gizmo last time we did that. I can't remember. We talk a lot about this in 240. Depth of field here. The f-stop is going to be important. And then this is the thing we're going to focus on. Is here, if we look through, and now we dial in the focus distance, you can see what's happening. And your values should matter because you modeled to scale, okay? If you modeled it weird in that it was like really, really tiny or really, really big, then you might have to go in and mess with these values a bunch. And so here, for those of you who don't know, when this number goes down, the blurry parts are going to get blurrier. When the number goes up, the whole image is going to get clearer. So here, our foreground is out of focus, our background is soft-ish, but our forks are the thing that's in focus. We can sort of hold down Shift while you're dialing this, and you can see it happen. Or you can just go focus on object, and then just click on the object you want to be in focus, right? So that makes that pretty easy. And then, like I said, if this number goes down, if I put it at 1, blurry stuff gets blurrier. If I make it 5, everything is much more in focus. You know, this is a little bit soft here, and that back there is a little bit soft. And so this situation makes our table texture situation more usable, in that if we're going to have the shallow depth of field, we don't need, you know, here where it's closer to the camera, where it would look blurry because it doesn't have enough pixel density, doesn't have enough pixels, doesn't matter quite as much because it's a little bit out of focus because we're using the shallow depth of field. So there's that. The other option is to go back into Substance Painter and export it again with the 4096 textures and bring those in. That might be an option there. But yeah, for those of you taking a photography class or are taking 240, we go into a lot more detail here, but what I write down in my notes is that a lower f-stop number is going to make the depth of field shallower, that you'll be able to have less of it in focus. The easiest way to pick what's going to be focused is just to click on here. Go back and look through the camera. Let's say I want the front chair in focus and everything else to be out of focus. So I just clear this out and then pick this chair. There we go. And it's still kind of blurry. I don't know. Sometimes this object thing is doing it based on the anchor point of the object, which in this instance may be far enough away from this part of the object to matter. And so if that's the case, your best bet is to use this and just hold down Shift and just sort of dial it in till the thing you want in focus is in focus, like using an actual camera, right? Holding down Shift is pretty necessary to make sure you can really dial it in there. Cool. Okay, let's make a wine glass and look at some of those issues. So let's get some reference here. Let's start with something fairly typical. So when you're looking at the reference now, I think you've got a better feel for it, right? And so is this something you're going to be able to trace with like sort of no-brainer style in Blender? No, right? It's at an angle, right? It's not the direct line. So you could certainly bring it in and use it as a guide, but you're not going to be able to, full on trace it. Whereas something like this, pretty close, right? In terms of getting the proportions here. Yeah, let's go with this for now. And so I am going to save this. I'm not going to model in here. Let's make a new one. And let's look at our reference. And here. And let's bring this in. Let's look at some sizing here. Height 10 inches. Okay. And so let's delete this. Let's make a new one. Come in here. Remember, this does all of our converting. There we go, 0.0254 meters. And then let's add some image reference, and I got that on the desktop here. Wine glass. There we go. And now time to calibrate. Let's grab the image and Alt-G, Alt-R, and let's rotate this. There we go. And what do I need to scale here? The picture or the cube? The picture. Why? The cube is already right? And so I need to make the picture match the cube. Putting on this, the X-ray, makes this a little bit easier. And then coming in here and doing the size here. And again, you want the thing to match this, not the image. The size of the image is irrelevant. And so may mean a little bit of this. And, you know, the image may not be perfectly symmetrical. So lining it up with the center, as we've discussed before, makes things a bit easier. And yeah, okay, that's pretty good. Let's go with that for now, and then we can drill down on this. So yeah, wine glasses, we could take the screw modifier approach and use a curve to come around, or we could use a cylinder with the sub-D surface. In this case, I'm going to use the cylinder with the sub-D surface so that we have a little bit more incremental control over the smoothing of it. And so I'm going to say only in orthographic view there. And over here, this is going to get renamed to reference cube, and then turn that off for now. And over here, let's save this whole thing in here. And save, and maybe be able to dial this down a little bit. And then let's make a new cylinder and make some changes here. I want to be conservative in the number of subdivisions because I'm going to add a subdivision surface. So again, though, I'm making a radial thing, and so 9 times out of 10, even number. It's going to let you divide it into half, divide it into quarters. Unless you're doing a 5-armed starfish, it almost always makes sense. So here I'm going to go 12, and then our radius, I'm going to say 3 inches, and then under depth, what was it, 12 inches, and it was 10 inches, and there we go. That gets me in the door. And now I can tab into edit mode and start to adjust this. So for instance, we can scale this down and figure out what our maximum is there. Probably bring this up a little bit and start to make some adjustments. Let's really just sort of like get the basic changes of shape, then see what other stuff we need to do in terms of working with the sub-D surface. So Selecting these when I'm in X-ray mode should allow me to scale stuff down, and then it's got to come back out here. So I'm just going to move this stuff up to where's the thickest point, like maybe right about there. And then, yeah, let's look at this. Do we have caps on this? I think we do. I'm going to get rid of those for the time being. So let's get rid of that one, just the face. And let's get rid of this one, just the face. Because that's going to change how the sub-D surface works. And so now if I come back to here, and I come back to here and turn this back on, there we go. And so now, let's go to edge mode actually, like so. And so I can E, and then I want to make sure I'm coming straight down. So then press Z to lock it and get to right about here. And then S, bring this in there. And then find our next change in shape right about here. E, Z, S, getting there. And then E, Z, S, right about there. And then E, Z, S, about like that, and then E, Z, right about there. Okay, and let's see what that looks like. Okay, feel good about the general profile of this. And this is going to be glass, right? So the double-sidedness of it and the accuracy of the double-sidedness is going to matter much more than the other stuff that we've made up until this point, where you didn't see through it and the way that light was bouncing around inside of it wasn't really something we were concerned with, right? And so we need to be able to control for those things. And so for instance here on the wine glass, there's going to be this internal part here, right? Because this part has thickness, and then in here it also comes up like this, which causes some stuff in there. But let's get the profile a little bit closer here. Let's come in and call this wine glass, and then let's go ahead and throw the sub-D surface on to see where we stand with this, and maybe a 2 there. And let's tab out and shade smooth, obviously, so we can start to get a better feel for what this is going to look like. And come back in here, and now we can start with some, controlling edges to try and get the shape a little bit more representative of what we want here, right? Deleting that face on the top and the one on the bottom is clear is important, because otherwise this would be doing some weird stuff up here at the top. Yeah, so here our Control R is going to allow us to move things. So we don't want to move stuff way close here. It's going to make a sharp edge. Just give ourselves a little bit more to work with. And then down here, Control R, let's say here, and then Control R, bringing this one down. And now I can start to Alt click and scale these to try and get the shape about where I would want. Right, so some balancing here. And so there's a little bit more roundness here. That's looking smoother. Down here, there is a sharp change here, right? So this is going to warrant a controlling edge that gives us a little bit more compression there. And here as well. Okay, feeling pretty good about the proportions. Let's talk about the rest of it now. And so we want to be able to extrude and have this inner part. And so we need to create a double wall that only goes this far up and in. And then in here, we need to have this part that comes like kind of up and in like this. So let's do the bottom one first. And so in here, if we grab this one and we inset, nope, that's not going to work. If we extrude Z and then we scale, that'll bring this in. And we can move either inset again. Oh, it doesn't like that. Sometimes if there's nothing there, actually we can adjust this by alt-clicking. We can get the inset to work if we grid fill. And then if we inset, there we go. Actually, we wouldn't want to grid fill to the end. And so I'm just going to F fill and then I inset. And then move it up a little bit. Depending on how sharp we want this lip to be here, that control R, whoops, loop cut allows us to sort of define the shape of where it sits on the table. And then this stuff here at the bottom, maybe this comes up a little bit. Like that. Okay, now for the other part, up here, I'm going to grab this and inset. Actually, nope. Yeah, if we fill, just F, and then inset, makes that process a little bit easier. So how thick do we want the wine glass to be? Something right about there. And then we can inset again, and then just start bringing this down. So now looking at it from this view would be useful. And so if we just move this down, you can see how we're starting to do this and probably scaling this out, kind of looking at not the sub D surface one right now, just sort of the basic geometry. And then extrude again. Extrude again, S, E, S. And these ones in here, maybe a little thick. So we turn that off. Turn this off for a second. Might be good to, actually, if we have this on and this on, maybe easier to do one of these. Give ourselves some other view of it here. All right, so use this for selecting and this for scaling here. So it's still a little thick here. Let's scale this one up. Push that out just slightly. This one here. I think it might be easier to see if we turn this off temporarily. And let's check this. Make sure we didn't turn it inside out at any point. And so in here, in here, I'm not seeing it inverted anywhere. Nor are we there. And yeah, it's all sealed up, right? So down here and up here as well. So all that's going to be pretty important. And now we've got something where we can really dial in the amount of necessary smoothness. If this is in a game or back on a table somewhere, you know, like this far away from the camera, that's plenty, right? We're going to want to get closer to it. So 2 seems to work. The top, yeah, the lip on the top also needs some definition. So I'm going to add a loop cut here to bring that up. And then, yeah, the Bo asked about using proportional editing for the interior of the wine glass. That would work too. That might be useful. I'm just trying to sharpen up the lip here, and same thing here, maybe from the inside. I can't see what I'm doing. Let's turn this back on. And then a lot of wine glasses have like a little bit of protrusion around the lip there as a result of some of the glass blowing technique. Oh, don't do that. Whatever just happened there. So any kind of curvature imperfection here is gonna like really speak a lot more for these glass objects. Okay, I like it. Let's save incremental. And yeah, so we want to okay, so here, there's some different ways to go about this. Let's do one here where we're going to paint it in Substance Painter. We want to be able to handle the glass, and then we'll bring this back and look at some of the interactions here that this works. Okay. Everybody ready? Here we go. So we are going to need to unwrap it, but this should not be crazy. We just want to be able to unfold this fairly easily. Probably a seam up here. And so let's do that. I'm going to save incremental one more time. Then apply this. Then there we go. There we go. Got everything together. Down here, actually, yeah, a little bit of weirdness there. There will be angles, so let's fix that before we apply the modifier. So I'm going to tab back in, turn this off, and yeah, so the one on the bottom, not quite as important, but here I think it's probably important to fix this. So delete this, then come in here, alt click this, and let's use the grid fill to fill that in to get some better reaction, and we'll fix the bottom too while we're at it. And so down here, delete that face, and then alt click, and then grid fill. There we go. All right, and so now when we turn this back on and tab out and convert to mesh and then tab in, we'll see better result down there of what's happening. That works. Okay, now let's unwrap this. So we're gonna want something here. We need to cut it up and down vertically. So the grid fill is wrapping that around. In Cinema 4D, there was a great way you could stop that. But anyways, here, we're going to need a lip seam there, and we're going to need a seam here as well. So I'm going to put this maybe on the inner part over here. And here. And we'll mark both of those as seams, and then we'll get this part here. So probably easier to do from this view. And straight lined up there, and so I'll click here. And then I know I'm in the center. And up here, at the very top, Control Shift click. There we go. And now we want to stop this like right there. So kind of zoom in. Need to get the rest of the way. Right here. Not that one, that one. Okay, that's good. That goes the whole way to the seam, the other seam, and down here, that does as well. Let's mark that. Let's look at the UV unwrapping. Okay, we're getting somewhere. So this is the entire inside, right? And so we want you want that laid flatter. This is the bottom. That's not bad the way that is. We're getting this straightened out, and so yeah, we'll see what happens here. We may want to straighten this one out, I think, because of the way things run up and down. Let's come in here and work this one out. and then there we go. And grab everything. And let's run this again. There we go. A little bit less distortion over here. And we should have something. Did I get something strange there? No, that looks fine. That's just that bottom part. And so here, if we come in and press N, and look at our UV toolkit. Here, Control L, grab these. Yeah, so let's look at what happens here. If I come in and bring in a UV checker, we can see, you know, it's not lined up with the shape or the UVs because of the way this unwrapped here. And then also doesn't, you know, sort of run with the geometry either. So in this case, I think it might be a good idea to explore having these turned into like a grid in order to fill up more space here. And I think this will work with the projection that we use over there. So if we grab tab back in, grab this tab, and then our button here that does this is Gridify, which is, I just saw it right there. There we go. Now, I knew what I had was a grid of squares, right? So that works in this instance. Now we see that this is lined up, cross and cross here, and we can do this. We should be able to do the same thing with the inner wall, I think. There we go. And you guessed it, Control L, average these island size, and then pack. There we go. And should be very well packed there. Cool. Okay, that works. Let's save this file, save incremental, and let's bring it over to Substance Painter. So I'm going to use the delivery kit extension here. And then over here, file new. Make sure I'm not unwrapping again. Beautiful. Looking good. Now, let's bake our mesh maps. Not a whole lot to do here with this one. Should be fairly straight ahead. But if we want to do something interesting with the lips of the top of the glass. Okay, seeing, so let's look here. We should be able to see the transparency. Let's go ahead and delete this paint layer. Let's just make a default fill layer. And if I remember correctly now, our default shader in Substance Painter, if we add a translucency, should be able to show us see-throughness. And so if I turn that on and turn it up, we're not seeing it because it is there in the shader, but we haven't configured said shader. So I go to shader settings, and then I come down here to look for enable translucency. Boom. Chaboom. There we go. And there we go. Did I double some stuff in Blender? Let's look. I think it would have showed up on the UV map if I had. I'm just gonna run a merge for the sake of it. That's good. Oh, excuse me. Let's look over here. No, I don't think so on the UV map. Blow asks if the inside grid matches the outside grid. And I don't think so. Let's see. Is what I'm seeing an actual thing, or is it just a Substance Painter issue? I'm feeling like it might be a Substance Painter issue because it seems to be like where these things are overlapping. I am going to do a test export here and bring it back. Definitely run into stuff like this in the past where there's like something with the Substance Painter shader that something looked a little funky. Because they do, you know, this tends to be on the cutting edge of the graphics drivers. And there's been some things where it was out of. Something with the roughness. We're going to have the roughness way down anyway, so that it's very transparent. Okay, I can still sort of see it. Let's see if it shows up. I'm going to turn it up just so that we can tell if it's there or not. So we want this translucency in the export. So we're going to do more to this. I'm just, you know, round tripping it here to see if we're going to run into the problem over in Blender. So export textures, USD, pick the folder. To here, and here, and new folder. This is going to be wine glass. Trying to stay organized. There we go. And now, Blender, the default one. Let's look at here, and so select the Blender Principled BSDF. And if we were to make this window slightly bigger, might be able to read these things. Okay, and so now our see-throughness here, we've been storing, hold on, let's see. Yeah, so the opacity is getting mapped into the alpha, but again, that's for masking, not the translucency will go into the transmission in Blender. And so the reason we're using translucency is because it's just a checkbox in the shader there. But we have the channel. So we need to get, right? So this is this tab doesn't have anything to do with what you're currently outputting. This is what you're currently outputting, this preset. To edit the preset, you come out over here. You don't actually edit the primary presets, you duplicate the preset, then you edit the duplicate. So I already have one here, but I'll make another new one. I'll hit plus, and so down here, new preset number 1. Right, I made sure I had the Blender Principled BSDF selected when I hit plus so that it used that as the, actually I did that wrong, never mind. Come back to Blender Principled BSDF and then hit this button so you actually duplicate it. There we go. And so now in here, I'm going to name this one Translucency 2025, just to differentiate it from the other one I've been making. And then over here, we need to, right, this whole window is telling you which of the input maps. So the input maps are going to be these over here, the things that you're working with in Substance Painter. How do they get mapped to the output over here? Mostly it's a one-to-one with like name conversions when we're going to Blender. When we're going to Unity, that's where there's that texture packing into one channel. You can see more complicated things here where lots of stuff gets thrown into one channel. Don't worry about that for now. Back to here. We've got everything we need except for the translucency. That needs to get into this map. So we need to create a new gray, because we don't need it to have RGB information. We just need it to have scalar information. We take our translucency and drag it onto there and say from translucency. Is it doing it? No, it's not doing it. Let's try it again. Let's say RGB and drag it over. We've got this set. It's working when I've done this obviously before. What am I missing? We make a new gray one. There we go. What was that? Why was that different? Gray. Grab translucency, drag it on there. If I say from translucency, it doesn't make the connection, right? You can tell because it doesn't make a little color icon here that's actually populating over there. But if I come over here and say gray channel, then that lines up. Let's try it a little bit differently. I'm going to take the alpha channel and say duplicate it. Then can I drag this onto here? There we go. Okay. Now the only thing it is, wait, no, that was the wrong one. So alpha channel duplicate. Drag this onto the duplicate. Say store it in all 3 channels. There we go. Then you got to change the name, right? So this is how it gets output. And so here under alpha, we need to change it to translucency. There we go. Let's give it a test. I need to be able to tell for sure whether our data is getting through here. And if it's just one value, it's going to be tough. So I am going to just throw some sort of noise onto the translucency channel so that it'll be obvious, very obvious what's happening. And so let's try it now. Let's export export textures. Make sure I use the output template I just set up, which is at the bottom. Here it is. And put it in this folder. And let's export. And it is exporting a translucency map. So that's good, but let's see what it looks like. Is it actually getting the data that we want out of Substance Painter? Yay or nay?
I mean, that's probably what the UV map looked like, right?
Yeah. This is the noisy information I just threw on there, and it is going through into the thing. It's really hard to tell in the output template under this. This window is hard to wrangle here, right? And so this is going to here. That shade of gray is the same as this one, so this data is going to there. So again, the process was duplicate the Blender template. Select, hit the duplicate button. In the duplicate, first of all, name it something probably with translucency in it so you know what it's doing. Then duplicate the alpha channel by, again, pressing the duplicate button. Then rename the alpha channel to translucency, and then drag the translucency information onto here, the key being, it didn't seem to like it if I said from translucency. I mean, now it's doing it, but I'm not sure whether. So either from translucency or RGB channels should do it. And so now we're getting that information out of there. Okay, let's just load this in Blender once to see if those weird triangles are showing up. I have a feeling they are not, but let's just be sure. So we'll open our table scene and we'll bring in the wine glass. model to scale. So again, looks good. And what does it look like when we turn this on? So yeah, now we're in the world of wrangling the translucency. Let's look and see what's going on here. So come back here to object, and we may need to do a little bit of work here. Again, most of the work is done for us, but there's also this issue, transparency is hard to do, quote unquote, for real, or it's just slow. So actually, the first thing to do here before we start wrangling a bunch of EV settings would be to check it. Let's just switch over to cycles and see what this looks like. Okay, so it didn't bring in the map. See how there's base color, metallic, roughness, normal? Okay, so we're going to need to bring that in ourselves. If we come in here to transmission, we start turning this up, we see that it gets see-through-ish. The other issue here is in the material. Ray trace transmission. See affects this slightly in EV, and then we need to get the actual transmission information, right? And so this case, this turning this up does make it see-through, but it's just uniform. We're not reading any of that map data that we brought in, that we made in Substance. So in here, in here, in here, here, here. There we go. This is the missing map. There's 4 there. Here's the 5th one. And so, again, this is not, whoops, don't go into that chain of stuff there. There we go. This is just black and white, so it needs to go to non-color. And then, oh my gosh, stop doing that. This goes to here. This goes to here. And yeah, now this is representing that noisy data that we had before. Obviously, we're not going to do it like this, but this is what we're talking about. And yeah, making sure that under the material, you have ray trace transmission checked. Makes a slight difference there. Again, I'm in 4.5. Yeah, and so now we're able to make that work. So let's go ahead and paint something a little bit more interesting here. So yeah, this triangle situation, I mean, let's zoom in over here. The good news is that doesn't seem to be happening here. Let's zoom in and look at it a little bit more closely. I don't see it. Yeah, I think that's just sort of a weird Substance Painter GPU bug for right now. If we switched it, let's just see if, I don't think it'll show up in cycles either, but we'll look. Yeah, I don't think it's happening there. So hopefully that holds true for you guys as well. That's there. Okay, so let's do some things where this is actually going to matter. So for the time being, we'll just ignore this weird triangle situation. And here, so we obviously want this to be very see-through. So we're going to turn this up quite a bit, maybe just below here. And let's say we want part of it like a gold rim. Let's make it silver. I'm not that gaudy. So here, let's go ahead and make some silver rim, and a little bit of height difference here. This is going to be metallic and very shiny. And we only want this on the top. And so in this case, I think our easiest bet is going to be to make a black mask. Look at this in orthographic view and hold down Alt so it lines up, and Shift. And so now we can come into the mask mode, come into the polygon select, come into the polygon fill. And now that issue of the polygon selecting the whole way through the object, we can kind of use to our advantage to create this pretty clean lip around the top of it, like so. And so you can see, make it a little bit raised there from where it was. I might blur this mask just a few pixels. And then maybe give this a little bit of texture. Chill that out. We're going to see that seam there a lot. So I'm going to change the projection on this to triplanar. That helps. Yeah, this being butted up against this maybe presents some issues here in maybe having a little bit more space in the UV map there between the islands would be advantageous. Let's go back to UV projection. And we'll call this glass. One of the other things we can do here is on our base, translucency, roughness comes way down. I think you can make it look more like glass in the shader again. If you come in here to translucency is on. And the index of refraction is just giving us the strength there. That's fine for now. Okay, so we got that metal rim on there. Let's get some fingerprints on this glass. So I might do that in a separate fill layer here. And let's experiment with some things. What if we just put them in roughness? And look at the tiling. You know, too much, and you can see it clearly happening there. In our case, we're getting that distortion because of the gridify here. So maybe it makes sense if this is more triplanar. And then adding a levels to the roughness, which is the only one we're working with here. And sort of just bring in like a little bit of that. So that's when it's just on the roughness there. If we were to give it that looks pretty good, convincing. I mean, depending on how close we get, I mean, I don't know, I like that on the roughness channel. The other thing you can experiment with is having it on the translucency channel, right? And so here, let's see if we get a major difference for what's going on. If we put the same map on it and we were to work with the balance, again, a levels here. And since we mapped both sides, right, we have the inner and outer wall, you have things happening, you know, like there's information happening on both. The triplanar means that we don't get these weird stretched fingerprints there. They're just sort of in. If I only wanted fingerprints on the top, like where people were grabbing the glass, again, a black mask and a paint. And I could sort of bring those in only where I wanted on the top. And if I went inside here, a little bit inside. Again, I have a soft brush, so it's really kind of judiciously applying that. And I'm not getting as much on the stem and everything, depending on how far down I would want to go here. And probably want a little bit of glass wobble here, right? Again, CG too perfect by default. Make another fill layer here. And again, I'll call this glass wobble. And it'll be in the height. So in here, let's get some sort of very We don't need a lot of detail. Just make it a little bit less regular. Yeah, we'll try this into the height there. And first thing would be the scale. There we go. Maybe right about there. And then, of course, salt to taste. Right, so there's none. And then adding just a little bit. So now, as you would look around, looks much more like a blown glass thing. Figuring out exactly how much of this you would want. Let's see what's going on there with the... Is the seam a total result of this? It may be... How about the fingerprints? So in my UV map, having a little bit more space between those two islands, I think, would be getting rid of that one inconvenient thing. I'm not going to go back and fix it right now because we're almost at the end. So... Okay, let's see how that works. So let's go ahead and save. And we've already got the, actually let's clean up these names. So this is going to be wine glass. And let's export with our translucency, right one. That's all good. Run that again. Come back here. Let's get rid of this one. And switch back to EV for the time being. And bring that in. Let's save this file. Back over here. Let's bring it in. There we go. And selecting this, we need to come in and ray trace transmission. And yeah, the node wrangler is not hooking up our translucency information, so you need to add that one manually. So coming in here, bring that in. Set it to non-color and run it into the transmission weight. Let's see if we see a difference in if we just send this in here. All right, what exactly are we seeing here? Is this a lot of the HDR reflection? Let's check over here. Okay. Let's see what's going on with the index of refraction. So for glass, I believe we want 1.3. .5-ish. Let's set that correctly. And let's look over here. Let's see if it looks any better in cycles. It's still like super reflective. Let's see if we can make sense of this. Usually it looks a little better coming out of it. If we were to build this up piece by piece, let me disconnect this. Okay. And so if the roughness is way down, yeah, I think this HDR is maybe, let's try a different one. What's going on, Blender Kit? Okay, let's look at this one again. Yeah, so IOR of 1 is completely transparent. The light will not bend going through it, like so. But glass should be right around 1.5. Although we've had some weirdness with this in the past. Let's try something a little bit lower. 1. Okay. That might be a little bit more what we're after. Yeah, using the real world IOR value seems to like not, even though we modeled a scale, for whatever reasons, what happening in, yeah, that's a lot. Okay, let's hook things back up. That helps our lip there, that's back. Here is our roughness. There we go, that gets that happening. And then back here, our normal map going into the normal, and our translucency going into the transmission. So we're getting some of the action on the surface. We bring down the alpha, and it starts to look a little bit more see-through. Yeah, I'll do some research as to why the values are kind of strange there. And I have a feeling if we had a different HDR, but it's not loading one for right now. And let's check in over here. The only other thing here let's try is let's experiment with perhaps a different shading model. So let's look here. So if we run this in, let's see what happens in Eevee. So again, put it back at 1. If we were to bring this up just slightly there, that's a little bit better. And then for our roughness values, what if we ran our no, now it shows up. Okay. It's looking better, but we're just not seeing through at all. So the one major change there was under material, thickness, slab rather than sphere. Sphere is definitely more distortion there. Slab seems to be a little better. And then I could put in something that's actually a close IOR value, and that seemed to be a bit better. And maybe this film thing is that's slightly better. but we're still not really getting that double wall look in any instance. Sort of going through it there. Okay, so after all that finagling, just with the regular setup, once you bring in the transmission here, making sure that the material itself has, all these, glass wrangling, a lot of it ends up being things that are in the material shader code, right? So, ray trace transmission. Is that better? That seemed to get better. Let's look. Here's dithered. Oh, it's very slight. I feel like we're seeing more of the double wall there. And yeah, the sphere is definitely way more distorting the IOR, so we definitely want slab. That's definitely better. All right, it's pretty close. Let's see what we can do to get a little bit better, but that feels a little bit more in tune if we were to look at this under our focus distance here. Yeah, looking through the camera, I feel like that's better, although this down here still isn't quite doing what I would like. And in here. And in here. And let's save that and bring it back. We'll see if there's any other differences. This stuff does change from version to version in terms of like, the EV rendering improvements and that kind of stuff. So pretty close. I mean, the main thing is that the, actual see-throughness is mapped into the transparency channel, translucency channel, and that's what's happening there, which is good. But see if we can get more of the double wall look happening with what's going on. And we'll go from there. Awesome. All right. Talk to everybody on Wednesday. Look forward to seeing the cutlery